All right, let's just dive right in. We hear about AI, well, everywhere, right? But what's really going on under the hood? In this explainer, we're going to pull back the curtain on how large language models actually work. No hype, just the real mechanics.
It seriously feels like magic, doesn't it? You type something, hit enter, and this coherent, sometimes brilliant answer just appears out of nowhere. But what's actually happening in those few seconds? We're going to follow that journey step by step, from your keyboard to the AI's response.
And this right here, this is probably the most important thing to get straight from the get-go. We are not talking about consciousness. We're not talking about reasoning or understanding in the human sense. We're talking about math, statistics, and probability. And once you get that, it changes everything about how you should use these tools.
So if it's not magic, and it's definitely not thinking, then what is it? Well, it all boils down to one single core function: prediction.
At its absolute core, that's all an LLM is, a prediction engine. It's not deciding what to say. It is making a statistical guess over and over and over again for the next most probable word or piece of a word based on the gazillions of patterns it's already seen.
And where does it learn all these patterns? It happens inside something called a neural network. You can think of it like the massive, super complex engine room of the whole operation. It's been trained on a truly enormous library of text. The internet, books, articles, you name it. And that's what makes its predictions so uncannily good.
Okay, so before we can follow a prompt on its full journey, we need to get a handle on the building blocks the AI actually works with. Let's break down the core components, because they're super important.
First things first, AIs don't see words or sentences like you and I do. Nope, they see things called tokens. Think of tokens as the AI's version of Legos for language. They can be a whole word, like artificial, or just a piece of a word, or even a single comma. So let's take a super simple sentence. Artificial intelligence is powerful. The AI doesn't see that as a whole. It sees it broken down into something like this: a token for artificial, one for intelligence, one for is, and it might even split powerful into two tokens, power and full. Every single thing you type gets chopped up like this before the AI can even touch it.
Now, you might be thinking, okay, technical detail, who cares? But this is where it gets really practical for you. Why should you care about tokens? Because pretty much everything you experience as a user comes down to them. The price you pay, that's tokens. How fast you get an answer, tokens again. The limits you run into, all about tokens. Even the safety systems are counting tokens.
So if the AI is juggling all these tokens, where does it put them? That's where the context window comes in. It's basically the model's short-term memory. It's the maximum number of tokens it can look at all at once to make its very next prediction.
And this slide just nails the key limitation. The best way to think about it is like this. The context window is the RAM in your computer. It holds what you need right now, but it is not long-term memory. If you push too much info in, the oldest stuff just poof, gets dropped. The AI literally forgets the beginning of your conversation.
And you know, that window gets crowded fast. It's not just holding your latest prompt. It has to cram in your new question, the entire conversation you've had so far, any secret instructions or system rules it's been given, and any documents it might have looked up to help you. All of that is fighting for space. Okay, so the AI has tokens, it holds them in a context window, but how does a machine that only understands numbers possibly grasp meaning? Well, the answer is pretty genius, actually. It's a process for translating our fuzzy words into the pure, cold language of math. It's called embeddings.
Let's take a phrase with a pretty clear concept, something like AI security risk. In our heads, that has a specific vibe, a specific meaning, right?
Well, to the machine, it's not words at all. It's just this, a long list of numbers called a vector. Think of this vector as a kind of mathematical coordinate, like a GPS location for a specific idea and a giant map of concepts.
So what's the big deal with turning words into numbers? Well, once everything is just math, you can do math on it. You can figure out which ideas are close to each other. This is the absolute foundation of modern semantic search, and it's what lets an AI find relevant documents based on their meaning, not just by matching keywords.
All right, we have our building blocks. We've got tokens, the context window, and embeddings. Now we can put it all together and actually follow a prompt on its complete journey, from the moment you hit enter to the second you get a reply.
So here it is, the whole life cycle in 6 steps. First, your prompt comes in. Instantly, bam, it's chopped into tokens. Then, the system gathers everything it needs for the context window, your prompt, the chat history, any extra documents. And then comes the main event, model inference. The neural net predicts the most likely next token, spits it out, and then does that whole process again and again and again, generating the response 1 token at a time. Finally, those new tokens are turned back into words and get a last-second check by safety filters before they ever hit your screen.
So here is the absolute crucial point. During that core prediction step, that inference step, the model is not thinking. It's not looking things up. It's just running its prediction algorithm on whatever data is inside its context window. That's it. It's a closed loop just predicting the next piece of the pattern.
Okay, that was a whole lot of tech speak. I get it. But why is it so important for us as users to actually understand all this? Well, because it has very real, practical consequences for you.
This stuff directly affects you. That API bill you're paying, it's calculated by tokens, not words. Ever get a really weird, forgetful, or off-topic answer in a long chat? Yep, you probably just blew past the context window's limit. And from a privacy angle, just remember that your whole conversation might be getting fed back into that window with every single prompt you send. And when you understand the mechanics, you also start to see exactly where the security risks are. Malicious instructions can get snuck into documents the AI pulls up. The numerical embeddings themselves could potentially leak the meaning of sensitive data. The whole system is really only as strong as its weakest link.
And that's really the whole point here. This isn't just about being nerdy. Knowing how the engine actually works, it gives you control. It helps you write way better prompts, protect your data, understand the model's limits, and at the end of the day, get more accurate and useful results.
Which brings us right back to where we started. We are working with an incredibly powerful pattern-matching machine. It's autocomplete on a cosmic scale. So, the next time you sit down to write a prompt, knowing that you're not talking to a consciousness, but guiding a sophisticated prediction engine, how's that going to change what you ask and how you ask it?